All right, everyone. Actually, welcome to 1970s vintage computing. By the fullness of the room, I can see that we have a great deal of interest in this, and that thrills my heart greatly because I love 70s vintage tech. And so somehow I find myself here standing in front of you introducing all these speakers when I had no idea I was going to do this. But I'm very glad to be doing this because I have my own little exhibit called Forgotten Machines, and I love vintage tech there very well. So let us introduce our honored speakers if we can. We have an all-studded star cast, absolutely. And I would like to warmly welcome Dr. Granville Ott, architect of the TI 99 4 series of home computers and other TI mini computers. Next is Mike Douglas, YouTube presenter showcasing 1970s hardware and software. I should get to know you far better, sir. Absolutely. And then my friend, Mr. Dave Lovett, Usagi Electric, a YouTube presenter showcasing vintage computer restoration, construction of vintage computer themes. I'm sure I could add a lot, but we don't have the time for that. And of course, finally, one of our show organizers, Raymond Jett, proprietor of Arcade Components and longtime electronic technician with YouTube channel, I guess. Well, how many of you don't have a YouTube channel? 3 of you do, I know that, so that's pretty good. All right, so let's give these gentlemen a warm welcome and figure out where to go. All right, so I'm a moderator as of 5 minutes ago, so I guess I should be kicking something off here. Well, let's talk about 70s tech. Okay. Dr. Ott, may we begin with you? We would love to hear a little bit from you.
Okay.
About whatever you want to talk about with the things that you did with Texas Instruments back in the day.
I would like to step back a little bit earlier. And the first computer I worked with was in 1956, if you can believe that. It was an analog vacuum tube computer. And I won't spend time here talking about analog computers, but they did exist, and this was coming from World War II. And then I got interested in digital computers when in '58, the University of Texas bought the first digital computer to be used in the experimental science building to do research. And so I thought, I wonder how the digital computers compare with what you can do with an analog computer. And so that got me interested in that. And from when I graduated with my doctorate in 1964, I went to work for Texas Instruments in Houston, and they were doing seismic computers. And the seismic computers at the time were processing data that the big computer companies, IBM, Bureaus, Control Data, all had machines, but they couldn't handle the size and volume of data that came from a seismic record. So TI decided we will make our own computer, and they got into the computer business. But these were big, expensive, $500,000 type of machines, and in 1964, a $500,000 machine is a pretty expensive machine. And that then got us into mini computers because the semiconductor people would like to have a computer to control the manufacturing process. And so they turned back and said, if you can make this big seismic computer, surely you can make something to control the manufacturing lines. And so I designed the 860, a 24-bit machine. And then they said, well, that's a little too big. And then the next year they wanted a 16-bit machine. We want to go out and buy one of these new 16-bit mini computers. They're about so big. And they cost about $50,000 in those days. And the president of TI said, well, if you can make a 24-bit machine, surely you can make a 16-bit machine. So we designed a 16-bit, the 860 mini computer. And at that point, I ended up going to teach at the University of Missouri, and then I will jump a little bit forward because these were the mini computers, which aren't the small computers that you see for all the gaming and everything we do, but they're a predecessor to it. So the computers are getting smaller and smaller and less expensive. And so I taught for 8 years up at the University of Missouri and decided that I would take a sabbatical. And my boss from Houston was now working in the calculator division in Lubbock, or actually it wasn't in Lubbock yet, it was in Dallas. And I stopped to say hello to him, and he said, hey, we really ought to have the designer of a computer that goes into the home. We want a home computer. And my designer got cancer and died. And why don't you help design this computer on your sabbatical? I said, well, hey, it sounds interesting. And so we presented the plans for a home computer at that point. This was in 74, let's see, no, 76. And so now we're in the process of deciding, well, TI management was not interested in having games. They'd like, TI likes to have a very stern image and not a gamey image. So they said, you can have a machine that'll play games, but that's not going to be the primary purpose of the machine. We want a serious machine. So that's why the home computer, after 3 presentations to management, they finally approved that we can build this machine. And immediately upon doing that, I decided, hey, we aren't going to build this machine overnight. So I bought a house in Dallas. I had a house in Missouri at the University of Missouri. And 3 months later, they moved us all to Lubbock. So now I immediately bought a house in Lubbock, and we had 3 houses. But that was the beginning of the design phase to design a home computer. So to start with, we had to pick a CPU. Well, Houston made a 16-bit processor, and we were going to use a nice, very inexpensive 6502 processor just to keep the price down. But after a lot of wrangling, said, TI, you need to use a TI processor. We need to, make that processor move forward. So we ended up using the 9900, and that's how we ended up there with that as a processor that we're going to use. And as you look at the doing things, we wanted to run the thing at the home. We wanted it to be in color, not black and white. It's got to look snappy. And if you're going to have color, the only thing, the display is going to be more expensive than the computer. That's just face it. And so we were looking and saying, well, you already got the TV set, so we'll use the TV set. And then we looked at how do you get the signal into the TV set? Well, in those days, there wasn't a monitor input on a TV set. So we would go in through the antenna. And guess what? The FCC says, you can't do that unless you get it approved. And so, hey, that was going to cog everything a full year if you can't do it. So we came out with a monitor that we got from Zenith, and we ended up having a monitor that cost just as much as the computer, so it doubled our price right off the bat. But we got it out there. We had it out, and the keyboard, the keyboard cost as much as the computer did. It almost double your cost if you buy a decent keyboard. You want a nice QWERTY keyboard to go with, and they were really expensive when you go shop around about the various keyboards, because people may have equipment that use a typewriter type keyboard that you could buy are expensive, and it took a year for our mechanical engineers to design a inexpensive keyboard. So we ended up with a little, what we call the chiclet keyboard. Those of you who've played around with the early machines realize that it came straight from the calculator industry. And one of the reasons why we could do a bunch of the stuff was because we had our calculator business, which had a maximum amount of automation. when you make the machine to make it inexpensive and manufacturing calculators, you have pick and place machines that place all the parts on the board. The board goes through a assembly line which isn't touched by a human hand. A wave solder machine solders everything on. It comes along here. For the calculators, they have a little camera that looks at the display and fingers that go down and touch the thing. And so you can make a calculator in those days with 1 minute of human time spent making that calculator. All the rest of it was all done by automation. So there we were, just expanding that a little bit. Instead of having half a dozen boards in the pick and place machine, we'd have 2 boards, a long narrow board and another long narrow board, and pick and place the stuff for our main board. But the big problem was the mini computer, 16-bit mini computer, didn't come cheap. And of course memory didn't come cheap. And so that's where we launched when we went there. And so maybe at this point I might let these other gentlemen say a few words about their vision or what they have experienced as we go from the 70s to where we are now.
Well, I'll jump in right on your TI machine there. So in the late 70s, I was on a TI 990 mini computer. So which came first, the bit slice mini computer or the 99 processor?
The 99 processor actually was developed for flight control by the military computer group in Dallas. And that group then got transferred to Austin to work on mini computers, and the 980 came over, and they liked the 990 because it had a lot of flexibility in the way it was designed. Unfortunately, that cost a significant amount in speed, but that's where it was.
So yeah, so which was first, the controller IC or the mini computer that used the bit slice to get faster? Do you know which came first?
The computer came first.
Okay. But I was always intrigued by this machine because you had terminals like you're used to on a multitasking machine back in your college days and whatever, but it could do all sorts of graphics, well, you know, fields where you had like spots for name and address and all this stuff, and we would do programming for businesses and school districts. But it was just blazingly fast compared to a 9600 baud terminal. And come to find out, all the video cards are in the mainframe of this TI 990 mini computer, and you just pump video around your office to each of these CRTs, which is a keyboard that then uses baseband and goes back over the coax actually, because you're very few keystrokes. So I never saw another computer that worked like that, but it definitely gave very fast response time. The video would be a problem if you were trying to go, you know, long distances, of course, but I like that machine. And then, yeah, because I'd worked on that so much, I played on some of the computer you developed, and I can do assembly in this. Wow, same thing. I was surprised.
Mike, why don't you give us a 30-second introduction to the types of things that you are interested in and you cover on your channel, 30 to 60 seconds on that.
Well, the channel is an after effect, all right? So I got into this hobby because I'd always wanted an Altera when I was in high school but couldn't afford it. The typical story a lot of you probably had. And then 20 years later, I'm looking, wow, I could afford this. And I go look on eBay and says, but I'm not going to pay that price. No way. And so I looked, and in the meantime, I went out and developed the Altair clone that some of you might have bought over the years in the past that looked the same on the outside. I developed a cabinet for it and all. I said, okay, well, this is fun. And I learned all sorts of things about how the Altair worked because I wanted to make that work exactly the same. You know, with cover on, I didn't want you to be able to tell the difference. And so that's where I got back into all this. Now, my professional background is all microcontrollers and embedded programming, embedded systems. So, you know, jumping back into this after the fact was very easy. But, you know, so I'll do something, man, I really wish I had this. And so I'll make one of these. Well, you can't make one of anything for a reasonable price, right? Well, I got 5 of them or I got 10 of them. So on a forum, I'd mention it and people would want them. And the next thing I know, my hobby's turning into business. You know, well, I got to sell these. But my wife doesn't want to listen to me. None of my friends want to listen to me. So I'd make a video, you know. And they were all free to begin with.
Nice.
And then all of a sudden, out of the blue, YouTube says, by the way, we're monetizing your channel. I said, no. And then I went and looked. October, they decided they had the unilateral right to monetize your channel, even if you don't do it. So several years ago, I said, well, fine. If they're going to collect money, I might as well get it. So my YouTube channel is really nothing but some way for me to record what I did with a project and talk to somebody about it. But yeah, so I don't get the views like these kind of guys by any means, but there's a lot of information out there, and it's fun to go back now and then. Oh yeah, I remember doing that. So that's where my channel is. And the other main thing I offer the community is my website. All sorts of people use DRAMP all the time for all sorts of information about this era of computers. So a lot of that information came from Martin Eberhard as well. He's got his whole archive up on that. So
nice. Well, Mr. Usagi, see what you can give us in 60 seconds of all the wealth.
Okay, but I also have questions for you. So I'm going to follow that up with questions.
Please.
If that's okay. My channel is Usagi Electric. Unlike him, I try to force myself to be a filmmaker first, and then a hobbyist in this hobby second. So I probably spend a good 4 days every week on the editing side of stuff and developing the story and whatnot.
you edit?
Yeah.
Oh, I didn't know we could do that.
Yes, he edits.
Good Lord. I wish I could not live in the editing program. But the channel has gotten a little bit of traction, and so it's really fantastic to meet a bunch of people and talk about it. And I mostly work on, so I have a hard cutoff, nothing newer than 1984. That's my personal limit. I was born in '84, so I want to be the newest thing in the room. So most of my stuff is in the 1970s, 1960s, and I do have one machine from the 1950s. I have a 56 Bendix G15, which we currently think is it's the only running Bendix G15 in the world, and we also think it's the oldest running digital computer in North America right now. Not the world. The oldest running digital computer in the world is the Harwell Decatron over at the Bletchley Computing Museum, which is why I had questions for you. You said you started with an analog computer in the 50s, and I know that this is a conversation about the 70s, but bear with me for a second.
We had to get to the 50s before we got to the 70s.
We got to grow up. Do you remember what that analog computer was? Was it a Philbrick?
It was a REAC. It was a copy of a REAC made by the Defense Research Lab at UT.
Okay.
During the war, and it had been surplused, and the Engineering Mechanics Department acquired that surplused analog computer, and they were looking for someone to fix it. Now here I am, a sophomore in school, looking for a job, and so when I went looking for a job, they said, "Oh, we just filled that job, but the Engineering Mechanics Department is looking for somebody. Why don't you go talk to them?" And I went over there, and the guy the professor said, "Would you like to work on an analog computer?" I said, "Sure." First, I had done hobbies at home, which most all of the people here probably have done. I bought the first, when the 1N34 diode came out, I made my crystal radio really hop and all that kind of good stuff. So since I could solder and could speak about electronics, he said, "We need somebody to fix a machine." So he hired me. Well, the first thing I did, of course, is hop on my bicycle and immediately go and look in the dictionary and see what is an analog computer.
Yeah.
You didn't pull it up on the internet?
It would have been nice. And so as soon as I figured that out, I went back, and there was a senior. I was just a sophomore at the time that I was there. So the two of us fixed the analog computer and then had to learn how to operate it for all of the various faculty members that came out solving their chemical equations and their beam bending equations, fourth order differential equations and stuff like that. And so I spent a number of years until I had to go to ROTC summer camp, and lost that job, and when I came back, ended up at the Applied Research Lab. Those days it was a Defense Research Lab, but they changed their name during the Vietnam War. Anyway, that gave me a jumping off part in electronics, and then that led me to TI in Houston, where I designed the seismic computers.
Okay. So and I think this is going to segue into what you do here actually quite well. But you mentioned memory, and I think this is an important topic to talk about, because I especially after having spent time with the Bendix G15, which is 1956, and I have a Data 620 by Data Machines Incorporated from 1965. To see the evolution of memory.
Oh yeah, what type memory do they have?
So the Bendix uses rotating drum memory.
Right. That's what the IBM 650 uses, a rotating drum memory.
Yes. Yeah.
And they have two patch panels. You put one patch panel on, and you run it up to a certain point, and you take that off and put another patch panel on, and you run it again and feed the deck of cards in with the card reader.
Yep.
And all that sort of stuff. And so that's where the computing level was in 58 when they bought the IBM 650.
Yeah.
And then they went to the LGP 30. Yeah.
Libre scope.
And
So
they
again, we're not in the 1970s yet.
then they bought a control data machine after that.
Okay. CC 160 or something like that. That would've been
so
about the same size as the LGP.
about that time, I had left and gone to TI to work on, and we started with the seismic machines, and we went down in scale when if you can build a big, $500,000 to $1 million machine. And my job was to make them faster, because when they went from land data, which, you go and have all the geophones, and then you get that data in to process, then you have to move the line. You don't get a whole lot of data. Then when you have a ship that every 10 to 15 seconds sets off a blast and gets a whole line of data, then they get a huge amount of data, and the computers just couldn't keep up with it. And the big computer companies just didn't want to process all that stuff. So they told me, we got to speed this machine up. And so that was my first job, was to speed the machine up. And I sped it up quite a bit, about 2.5 times the speed of what it was. But then I came, and technology was just going nuts just like that. And so, originally it had a 1K memory, core memory, and it's using 50 mil cores, and normally they run at 8 microseconds for each cycle. TI learned to partially switch it, and you had to keep it within plus or minus 2 degrees or it would make errors. But you could force that thing by partially switching it to run at 2 microseconds. And so we had a 2 microsecond memory, and then by the time we did the first upgrade, we could get a 4K array running at 1 microsecond instead of 2 microseconds. And to make a long story short, because we're looking at smaller machines, that machine ended up in a picture of it in the museum in London, the Geophysical Museum, and the label on the picture said, "The fastest commercial computer in the world."
Mm-hmm. Okay.
Which was my design.
That's awesome.
And so at one time, I was a designer of the fastest computer in the world.
There you go.
There you go.
That's no small thing.
So I've long held the belief that even throughout the years, starting in the 50s with digital computing, all the way up through the 70s and 80s, the core concepts don't particularly change all that much. But the hardest part of developing any of these machines has always been the memory.
Oh, yeah.
That's always been the biggest hurdle to overcome. So they started with rotating drum memory. There was a lot of different things. You had mercury delay lines.
Those are incredible looking.
Yeah. You talk about some steampunk hell. That'll kill. Memory that can kill you is
They
good
look
memory.
like weapons.
Yeah. But then we got into core memory, which started becoming
Less lethal.
less than lethal. Started becoming quite common throughout the 1960s and even up into the 70s. So the
Right.
Data General Nova that I have out there is on core. I think Mark has a 1105 out here that's on core. And so this gets into, and then by the late 70s, we're getting into like full-on DRAM, 4116s and stuff. And so I kind of wanted to toss it over to Raymond because I know that you collect a bunch of parts and resell them. So my question is how often is memory the biggest thing that you're pulling and keeping and collecting? Also tell us who you are. I know you are. You're like a close friend. But they
So
may not
yes,
know who you are.
Raymond, in addition to, being a major organizer of this VCF that we're all here for, yes, please give us a little bit of overview of how you fit into all of this and so on and so forth.
Well, I grew up with it. I was the nerd kid that stood around the Radio Shack store at the back answering questions about the components, and then
That the
telling
staff
people
couldn't
about
answer?
and selling the color computers for them because they didn't know how to do anything with those either. I got into my business on the side when I worked at Cisco Systems. I was trying to do some repairs on some gear and looking for memory and could not find it anywhere. Some old 2149s, and needed them to repair a pole position board, and so couldn't find them. So I just I found a source for it on some old boards and harvested some memory. Nobody was making them new anymore, and I thought, well, if I'm having that hard of a time finding these old chips, I'm sure other people are. So I turned it into a business, and it's been in the black since it was 6 weeks old. I founded it in 2005, so coming up on 20 years this August. I've got memory chips going back to the 70s. You start getting into like 1101s, 2101s, and getting into the early DRAMs. You've got the 1K MOSTECs and the 4Ks. Like we're in the Apple ones. DRAMs are a pain because you've got to multiplex your address buses to get to them. That's how they can keep them into a 16-pin package for a 256K RAM. And they just keep jumping generation faster and faster and faster and larger capacities. And this is just, it's spurred on everything because now what you would have in a box about this big to have a 4K multi-card, the core memory that I'm thinking of for some of the older TI machines would now fit in the palm of your hand in 8 little 16-pin chips.
Well, plus you'd need boards to drive the arrays and read the arrays on top of the array itself. So yeah.
Yeah, and so now you're reading these dynamic RAMs with just a handful of chips, some address line multiplexers, and you've got your data go in and your data go out. You got your goes in and goes out.
But so DRAM is I don't do anything with DRAM, so this is like a new world for me. Other than be like, that one's bad, I'll replace it. So DRAM you have to refresh because it is decaying all the time.
Right, and for the time period we're talking about, you've got the miniature packages of the address lines, like I said, they're multiplex. It's not like the static RAMs where you've got 24 pins, 28 pins, and everything's laid out nice and easy for you.
So on a DRAM I know core. On a DRAM, is a read actually destructive, or is a read so slow that it doesn't matter? You're refreshing during the middle of that, anyways, right?
It's not destructive.
It's not destructive. Okay.
On a DRAM, the read does destroy the data. You have to read, restore.
All right.
It's not in chip. When they read it,
You have to read and restore
they read and restore.
Even on DRAM?
in a DRAM.
Okay.
The SRAM, you don't, but in the DRAM, you have to do a read and restore.
Okay. So it's in that sense, it's still actually quite similar to core memory, because core memory is also a destructive read.
Right.
Yeah.
Exactly.
It's done within the chip, though.
Okay.
Yeah, there is no separate cycle on the outside.
Down, destroys because you dump so much charge, and then you. I always say it was like you take a thumbnail, you take a bathtub and take a Dixie cup out of it. That's basically how much you get. So you swamp the thing, and then you gotta write it back.
Okay.
From the chip user, the DRAM is rewriting it.
So as a engineer at the time, if you were engineering with DRAM, you don't really need to think about the fact that it's destructive. As opposed to like if you're an engineer with core memory,
You have to
design the entire read and rewrite.
You do have to refresh it. It doesn't have its own. I think later on, I think they did. But
Yeah.
also,
Yeah, they had pseudo-statics where they did that inside.
The ones I deal with, you had to do it manually.
Yeah, you have to access every row within the refresh cycle time, But for a traditional video application, because of the raster nature of it, it sort of it's an inherent refresh because it's going to be reading all the rows as it's refreshing the display.
Only if you read all the rows, but
Yeah.
you may only be using part of the memory, so you've still got to go through and keep track to do that.
And that was one of the big things of the Z80 is it included the refresh cycle as a signal out of the chip during the,
I didn't realize that.
during the
Okay.
M1 cycle.
Yes.
So the first part of the instruction fetch, it gave a refresh cycle because when Altair was trying to do, I don't know how many of you are familiar with the Altair and their DRAM board, it was just an absolute disaster. Poor Altair, poor MITS had a lot of disasters, but it was just a total disaster for them. And there was no way to synchronize CPU activity in the wait states that an 8080 had with the DRAM, and no matter what they did, it never came out right. So the people that left Intel and did the Z80, that was one of the main things they wanted. It was that refresh cycle was integrated with the CPU cycle structure, so it never was refreshing when the CPU needed data.
Okay. DRAM is confusing. So one of the issues that we've run into, particularly with old DRAM, on when you're starting to get fast. So like the Centurion, for example, which is the prime 1970s, they have to initiate wait states because the DRAM is too slow. So it actually has 3 or 4 clock cycles that it has to wait for whenever it tells DRAM, hey, give me a value. But they have static RAM on the CPU. And this is actually kind of a common thing we're going to talk about this on Sunday a lot, actually, you and I, for the TI chip. And the static RAM is like so much faster. You're getting values out of the static RAM in like 70 nanoseconds. And that stuff you can do without a wait state, which I think is fantastic. On the Centurion, and I think also with the TMS 9900 and the TI 990, actually, the 990 mini computer, the CPU registers were all in static RAM that was on, it was just in like a memory address space. But that meant that in order for the CPU to, your CPU registers in RAM, like if it takes, 500 nanoseconds or whatever to get your value out of RAM, if that's your core register, then you can have the clock speed at whatever you want. It doesn't matter. That's your bottleneck. But you guys, particularly on the TI 990, ran really fast static RAM for a very low section where all the CPU registers were stored, correct?
Yeah, yeah.
That was like the 6810s on the TI 994A.
Yeah. So, do you have some of those?
Oh yeah.
Okay.
Yeah.
Yeah. So those are pretty quick static RAMs, right? Those are like 70 nanoseconds or something.
128 bytes.
Yeah. You don't get a whole lot.
Yeah, because they had bipolar ones for things that had to be super fast like that. And in the early days, the first EEPROMs were too slow. So that's why your 1702s all had wait states in them. The early Altairs and anything from that MSI generation as well had 1702s. They required the wait states. The static RAMs were, well, actually the very first static RAM in the Altair needed wait states too. It was over a microsecond, but that didn't last long. But the wait states was very common. Now Motorola came out with 6800. It didn't have the ability to do wait states. It could only do a clock stretch. It couldn't be put into a permanent wait state where you could stop the front panel. That's how the 8800 front panel worked, is it just put it into a wait state and it sat there forever thinking it was waiting on RAM or memory. But the 6800 could only do a stretch. So they were already banking on everything being fast enough not to be an issue. And they, put their die to other use rather than the wait state logic.
The logic inside the 9900, though, was all dynamic. It was actually having to keep running, too. If you stop the clock on a 9900, it would die.
A lot of early processors were, yeah.
All the internal nodes were dynamic. So.
I remember the first static was like, wow, this is cool because now you could just stop the clock and save power. Yeah.
1802.
But if I understand the 9900 correct, and you can jump in on this, you never stop the clock, but the 9900 does have a hold pin, a hold signal coming in that essentially high impedances the data bus, the address bus, and all the control lines that they use to essentially for DMA.
I don't remember the 9900 that well, but the clocks had to keep running even when you had.
Yeah. The clocks are always going.
The pins, but if you stop that chip, the logic inside will go crazy.
Yeah.
But the 9900 has a wait state.
Yeah.
Yeah. It has a hold pin, right?
No,
Yeah.
wait, it actually
There's
has.
two different things.
It's got two. It's got both.
It has because on the-
Can't
on the-
stop the clock on a 9 number, dude.
Yeah, it won't
Yeah.
stop the clock, but you can put, because for the 4A to do it was an 8-bit peripheral bus, but
Yeah.
16 bits internally. So the 2 clock cycle memory access on the 16-bit bus turned into 6 clock cycles because you have to manufacture artificially the 2 8-bit accesses.
Okay.
And that's done by 34 wait states in the 16-bit cycle to get for a total of 6 clock cycles.
So somebody asked me this question earlier today, and it might have been you, I think, actually. I'm going to blame you anyways.
Blame me, please.
Somebody said, like, if you've got, because you guys were developing the TI-99 in the mid-'70s, so we're on topic. You essentially have an 8-bit machine that you've developed, and then you have the brass saying, no, you need to put our processor in it, which is a 16-bit processor. How come you didn't just use 8 bits of the processor? Why go through the extra effort to multiplex it?
Well, the intent all along was to have an 8-bit processor in order to minimize the amount of memory chips you have to have. You know, we would have, you know, it just drives your cost up to be forced to put in 16 chips. And so that's why we're keeping it at 8 bits is strictly because memory is a big part of the cost. Now, as it turns out, using the 9900 chip, that then became a chunk of the cost. But if we were using any of the 8-bit chips, they were much less expensive, but we didn't have that option at that point. I had the money from corporate to design an 8-bit processor, custom processor, which would be running native code GPL. That's one of the reasons why we picked the GPL, is because we were looking ahead to the point of having a processor that ran native code chip, the instruction set. And so I worked with our software guys, and they came up with the GPL as the instruction set that would keep you isolated from the processor. So at any point, if you change a processor, it doesn't change anything that you've done in the computer system, which is the same thing that got Bill Gates his development, is that he had developed a compiler which had compiled to an intermediate set of codes, and then all you had to do is to change the flow into the instruction set so you could make it run on any processor. And so within a month or two, you could take and port that to no matter what processor you had. And that's what, you know, he had to get his business stuff going. And we were wanting to do it that same type of thing with the reason with the GPL. And we would have had a GPL processor, except the calculator people wouldn't let me use any of the circuit designers. And, you know, Lovett considered the management in Lovett considered itself a calculator company, and we were just a thorn in their side.
I mean, to be fair, like, Texas Instruments dominated the calculator market in the 70s.
Right.
You crushed it.
And so they figured that we were just that it was one of these things that was going to go up and it's going to go away. You know, that for one thing, they knew that TI wasn't going to become a game company per se. The only reason that TI did any games at all was in order to stimulate the market to buy the computers, and then to, you know, everybody thought that the graphics memory was designed to limit all of the software to TI. The purpose was to eliminate having to write any of the software. The GROM was designed so that you could make it down to one mask level and have them in storage, and then for the price of one mask, you could have a custom GROM so that any guy that is developing software, even at home or in his garage, for $1,000, he could have his own personal GROM, and it couldn't be duplicated. So that we had software protection before people figured out how to protect software using software. And so the whole game was, but the press thought that we were denying everybody from doing it. And it backfired because nobody started demanding GROMs where, for $1,000 a chip, that's just a real bargain for having custom GROMs for your software.
So I'd like to take a few steps back here, and let's, since the general topic of this is technology, computing technology of the 70s, let's get a better picture of understanding this this decade as a time when computers went from big machines like the IBM mainframes that would only fit in a room or at best fit in the size of your double-sided American refrigerator into something that all of a sudden can actually sit in front of your home television, and you can actually learn to type on and do something meaningful with, maybe even write a program or two. All of this, to the best of my knowledge, all of this happened in this decade. So there were some major, major changes that you, Granville, were involved in, and all of us as collectors and aficionados of this technology kind of celebrate and I suppose marvel at. So I thought memory is a very important thing, and I'm glad we started the conversation there because it really was so pivotal. But there were so many other things that also had to be solved. Granville, you mentioned that that one of the things that had to change was if you needed to offer a cost-effective computer for the home, that you couldn't include in the cost the monitor. And so the utilization of the home television as a color monitor was an important thing. This is something that already existed in the video game world some years earlier. And what I'm curious about is, were you able to play off of any of those things? Like the Atari released this, the 2600, very famous, and it used RF to send to channel 3 or 4 on your television. The Commodore VIC-20 released only a year before the TI-99, of course, also did that. So many other games did that. Yet you still had to go through the FCC to pursue that as if it was a new thing. Can you talk a little bit more about what that was like and what some of the obstacles just for us to be able to see the displays of our computers on our televisions in the late 70s and early 80s? To go into the antennas requires that you get FCC approval. I mean, anytime you're generating RF signals that are detectable, you have to get FCC approval. That requires time. So all those games that you know came out, they had gone at least a year ahead of time. I see.
So they got that done and behind the scenes. So if we had some people from their company here, they would be able to tell you that they went through all the pains to get the FCC approval to have their device that hooked in. We thought we could do it right away, and you can't do that. Now, one of the things that I would like to mention is that people were thinking of small computing systems as early as 1965. When I first went to TI and was working on the seismic computers, they also had me looking at smaller machines. And at that time, DEC had developed a machine. This is before they came out with the minicomputer. They had developed a 8-bit machine that had 8 instructions. That's all it had. And I was looking at whether TI could build a machine that had, was similar, competitive, an 8-bit machine, because it would be really easy. It doesn't take much hardware to make an 8-bit machine with 8 instructions. I mean, that's something that you can put on a chip even in those days, it wasn't long before a chip could handle something like that. But they then moved up and finally decided not to put that machine on the market. But I was looking at what kind of machine could we build that would be competitive with a DEC machine. And so we looked at the 8-bit, we looked at the 16-bit. So I was looking at the really, really fast stuff as well as the really, really simple, cheap stuff.
And the FCC certification drives the cost drastically up. If you look at the early Atari 2600s, they had cast aluminum housings that they kept the main logic board in.
It almost offsets the cost of providing a color monitor with your system.
Wasn't that the 400 and 800?
400, 800 had those, yeah.
Yeah, and so did your heavy Sixers and the early Ataris.
So the very
2600s.
first, what do you want to call them? Personal computers. You had like your Altairs, your MSIs, your Horizons. Those were for hobbyists, probably more like you than it was for the home user and the kids to play games on and that kind of thing. To me, I'd delineate them by, I don't ever want to own a plastic computer. I want the metal ones. Although my back's not so happy with that decision anymore. That delineation kind of separates some of that too. Those very first ones didn't even need, or maybe nobody cared yet, conducted in unintentional emissions. Pretty soon they were all by the time Compaq and PCs were out, you had to have all the metal cages around on the inside to make sure you didn't have unintentional radiations from all your digital devices. But as soon as you go into being an intentional radiator, which is what the RF modulation would be, I mean, my business has devices that you communicate over radio. And we have to get approval for all that. An intentional radiator is a whole different process than, the unintentional or the conducted emissions into the power lines and stuff. So these companies had entire departments to handle that. But a lot of the first computers in a wood case, I mean, that's why you have some early ones with a nice wood cover, and then later they were metal. It's because the FCC started saying, hey, these are not just toys, these are turning into real businesses. You guys have to meet emissions requirements. And so, that started making things tougher and more expensive.
Being built by the person who's going to be using it, not being sold as a complete thing, probably also had something to do with that.
There is an exception for kids, yes.
Yeah.
So there's one aspect of this that we haven't talked about. It's an aspect that you and I both hold very near to our heart. So we've talked about the processors and all of that, and like honestly, I don't see a huge difference in processing capability between the early 70s and the late 70s. Early 1970s processors were incredibly capable. They were just bigger. They did get smaller and they did get faster, but as far as like raw capability goes, there's that. We did see an explosion in RAM memory, but one thing, and I think this is particularly for you and you, that I feel like home computers did not get their hands on at all at least deep until the 80s was storage, big storage. So the TI 990 was, depending on which model you got, you could get them with like various CDC drives. It's like anywhere from the 10 megabyte Hawk up to larger things. The Centurion had, of course, the Hawk and the Phoenix and stuff like that. So CDC was kind of a big name in this. But I feel like at the beginning of the 70s, you had stuff like the Diablo drive, which was 2.5 megs.
Yeah, it started out as 2.5 per platter.
2.5 megs. Yeah, so 2.5 megs at the beginning of the 1970s, and by the end of the 1970s, we had hard drives that were well over 100 megs. Deep into the 200 megs, 300 megs.
A lot of platters.
If you had enough green in your wallet.
Yeah. I never saw that at home in the 70s.
Yeah, in the 70s. So we're talking
washing machine size drives that fill this room. 24.
Even big platters were like 5 megabytes each.
Yeah, and if you had 15 of those.
Yeah.
Yeah, but for your home computers and the home brews.
So this is the question for you guys: is when we're talking about home computers, you with the Altair and you with whatever you've got.
Whatever.
If we're talking about big storage in the 1970s, like what do you come across?
Big storage in the 70s was 5 1/4 inch floppies on the home computer.
That changed everything.
That was it. That was the big thing. Before that, it was all cassette. You had the different
tape,
different cassettes with the different speeds, different standards. And
and of course you just encountered this because cassette technology would have been much of a low density conversion to audio instead of the higher density.
So the tech
tape drive you now have.
Yeah, the tech trend that I have is doing raw flux transitions as opposed to
FSK.
Yeah, FSK.
Yeah, but see, that's one thing processor technology did with the SOL-20 is it has to remain within the bandwidth of the audio processing on your cassette players, but theirs was technically just phase shifting. In fact, they used the exact same FM encoding as single density disk drives.
Okay.
Where basically you have a clock pulse every X microseconds, and if there's one in the middle, it's a 1. If there's not, it's a 0.
Yeah.
They actually put that on the tape.
Okay.
And they got 1,200 baud out of it. Yeah.
Okay.
Before the disk drives there was a period where you had digital drums that when I wanted to put external storage on the seismic machine, I added a drum memory because disks there weren't disks available at that time. It wasn't for about 2 more years before the IBM disks were becoming available, and then they went with the disk pack with the multiple platters with the ones that you could just lift the whole thing off and put another pack on. But before you could go to the drums, you had tape memory. The first seismic machine used a loop tape. You had a long loop tape that could hold a full segment of seismic data. Seismic data's got like 32 channels of data, and you have your about 10 seconds of data at sampled at a kilohertz, and that all comes continuous as one continuous amount. So it had the 1-inch tapes, and TI in Houston was building high performance tape drives, 1-inch tape drives, and so for the machine they had a 21 channel across the tape for a tape drive, because the drums didn't come out until another year, but the drums had a short period of time. Someone figured, hey, for that amount of volume, you can put a lot more data if you had a spinning circuit. If you already got something spinning there, if you just took this drum and cut it into a bunch of disks, you got a lot more surface to get a lot more data. But these drums were, great big space, and a small disk could hold all the data you had on this great big drum. But the whole transition of memories was going, they were using everything imaginable to try to store data. And people thought that the memory chips, the first 1K static memory chips were both expensive and not very much memory. So, but the memory chip business moved really fast.
It grew the fastest.
I mean, as soon as you got something designed, whatever memory you had in there was obsolete, or may not be obsolete, but it was obsolescent.
Which I found remarkable about the processor. You think about it, is the 6800 and the 8080, slight variations of that, they held their place for 5, 6, 7 years until CPM was finally given up. I mean, the Z80 wasn't much better than an 8080 when you get down to what you could do with it in total speed. The 6800 could keep up with those. Yeah, you had a 6801 maybe afterwards, something to simplify it, or an 8085. But in terms of what we saw in processors in the IBM PC era and clones, every year you were doubling gigahertz. I mean, it was just incredible. But back then, the CPU stayed stable surprisingly long, which allowed things like CPM and all to take off and develop. So if, like you mentioned, the 5 1/4-inch floppy was like a whoosh, and the market took off, because now instead of taking a half an hour to load an assembler with paper tape, or even 10 minutes on a cassette, now it's done in a couple seconds. I mean, it's just a world of difference. It made it usable.
That goes from the, you got all the industrial computers with all the super fast stuff in the very large storage space, but there's one thing, and I learned this part when I worked at a manufacturer. You got a target cogs you got to hit for your market, and in order to do that, you have to make compromises. That's why you have things like tapes, and the floppy disks when they first came out were crazy expensive, but the demand for it just dropped the price drastically.
Well, the 8 inches were a lot nicer and faster and bigger, but 5 1/4 came out. It was about, North Star is the ones that really pioneered. It was about a quarter the cost of your typical 8-inch floppy. So suddenly a person could consider buying one instead of just, a business that was trying to use it for accounting or do something with these.
A lot of people think that's what made the Apple IIs, that Wozniak came up with a way, it wasn't a full, his density went down a little bit, but he made the cheapest, the Apple II had the cheapest.
That was his genius.
By a lot. And that's what made.
Yeah, he took the board off.
He could do things in software in proms that was just fantastic for keeping the cost down.
So really, the Apple II really changed the thing, because everybody else was using tape. Then there was, of course, Coleco did the Atom with this fast tape. That didn't work out too well.
Design error with power supply pulses erasing tapes. Yeah.
Well, yeah, you think about it, the Altair was 256 to 1K on their board. And just a few years later, 16K boards, you fill out a 64K memory space with some 16K boards. And by 80, there were 64K boards static, that had those EEPROM, the same pinout as an EEPROM. Those boards are so reliable, and you could put an EEPROM in one socket if you wanted, and suddenly you've got you don't need a separate EEPROM board anymore. And of course, Dynamics would be cheaper than that, but these were rock solid in these early S100 machines. So your RAM, just huge exponential increase.
They got cheap enough they could put out the Lightspeed card, which is basically a solid state disk.
Yeah. But then the processor was the same this whole time. Well, 2 megahertz to 4 megahertz. That was there were some 6s, about the time they were giving up and going to PCs in 81, 88.
The Altair was primarily 8-inch floppies at that time, though, right?
Altair's own design was an 8-inch floppy, yes.
So when did the 5 1/4 come out? Because you're talking about like that was revolutionary, but I feel like that was very late 70s, if not into the 80s, wasn't it?
76, 75, 76.
76.
That early?
Yeah.
Yeah, because the first 8-inch floppy drive was 1969 by Shugart, who worked for IBM. Then he went to Memorex.
IBM. It was
He made another version in
Don't get the IBM guys
1970-71. Then he didn't like Memorex, so he designed his own Shugart drive, and you can find them right outside this door, hiding under a table right now.
Yeah.
And we have those all
Those
around.
things
So
are insane. I can pick up 8-inch media and an 8-inch Shugart drive and get good reads, good writes, get that disk drive working all the time. It's just incredible.
They're crazy.
Back in the days when I would use 3.5s, I never trusted them for the next day. And yet, it's incredible. Even the early 5 1/4s are relatively reliable, but the 8, even the old media, it's just amazingly reliable. Although it wasn't pushed to any limits, right? You had a large surface with lots of spreading of the bits, and
yeah, Wiki says the Shugart released the 5 1/4 in 76.
yeah, that sounds
That's
about right.
way earlier than I thought it
Yeah.
was. That's crazy.
Well, you had the matching drive with the Altair 8800B, the 5 1/4.
Okay. Oh, that's right.
Well, Altair never did. Well, Altair, they made a mini floppy that had total of 78, or those first 5 1/4s were about a quarter to a fifth the amount of storage on a 8-inch. So it was a pretty significant drop, but that quickly changed with double-sided and then later double density. And then
The high density 5 1/4 was essentially an 8-inch.
yeah, no, I do that all the time. Yeah, so if I need an 8-inch and I'm not in the mood to move it, I use a 5 1/4 high density. Yeah,
But it sounds like really the point. Sorry to hijack that there, but it sounds like really the point of all of this is the 70s was a very, very unique decade in which it was so many things were just colloquially the Wild West, where there are no rules. We're developing something. We don't know what it's going to look like. The pieces that we have to work with are very different from the way they're going to look, very different from the way they want them to look. And so the thought processes that went in to developing some of this stuff are things that we may have never considered. And so for those of us who started computing in the early 80s on machines that were already on our color televisions, and going from there really didn't have a concept of what the thought process that had to go into bringing those computers to our homes, or even revolutionizing the computers that could be put on a desk in an office and be self-contained. So, being able to hear and talk about a lot of those Wild West concepts and how different they are, I think, is really where we want to continue to go with this conversation. So we've got about half an hour left. So I think we're doing pretty good. Who would like to take this elsewhere before we open this up for questions?
So it's interesting that you talk about like putting things in a desk and making things set up for home, because I've seen plenty of promotional material for mini computer manufacturers, TI included, Centurion as well, that put things like a CDC Hawk drive or a CDC Phoenix drive in a desk that you sit at.
Yeah.
Yeah, the computer was the desk.
Yeah,
I forgot about that, but I shouldn't have.
TVs were furniture too back then.
Yeah. So that's not so much the issue, but the issue is that I have a functioning Phoenix, and I have a functioning Hawk drive, and I have hearing loss, and so who in their right mind put one of these things in a desk and was like, yeah, that'll be fine. Like, they're so loud.
That's fine for your bedroom,
It's
home
crazy.
office.
The number of fans in all these things, as you shut them down one by one, it's like,
Yeah.
In fact, even in some of my videos, I've done that. I've given that.
What are you going to say,
finally,
Raymond?
okay. And in the teletype on, it just...
Raymond, go ahead.
Some of the beauty of the 70s is the advent of, the surplusing of electronics from these major manufacturers. And so you get these magazine articles, radio electronics, and other places where you would see these microprocessors and these memories come out, and people building circuits and publishing things. And you see a hobbyist drive, just fanatical one, coming in around like 1976 and on up.
Yeah, fantastic. Well, it begs the question, what's so interesting about this panel is most of us in the room are aficionados of this vintage technology, and some of us were users of this vintage technology in the day. But Dr. Ott, you were actually one of the people back developing it in this decade. And so I'd like to ask the question to you, how does it feel now? How does it hit you that you're sitting in a room full of people who not only use some of this technology, but 40 and 50 years later are here to celebrate it? Did you ever think you would ever see anything like this? And now that it's here, what do you think of it?
Well, there's a couple of things. One of them is when you are looking at the technology that you're getting ready to use, it's hard to tell which of it is just going to fall off over the cliff, because the technology is moving quickly, or which of it becomes kind of stable and usable. It may be slow, but it works. The thing is, the other thing you have is a whole bunch of this depends on the user. If you got a lot of users, the price is inexpensive. So the best technology may not be the winner. The winner is the one that's most used. Mm-hmm. And what's most used depends on a number of factors. And there's the gee whiz that you might just hit the right window. You have something that was really good, but it just didn't appeal to people, and they didn't buy it. So it gets hung up at a price that's not competitive anymore. And something else that wasn't all that good gets hot, and it gets so inexpensive that nobody can compete with it. You can have something that's really great, but it isn't going to compete because this stuff, there's a learning curve in volume, and when you go to the tens of millions, you reach a competitive level that almost kills the market until you have some major breakthrough that finally gets over that hill. So it's hard to predict. I mean, here you are working with something now, because most of us here are talking, at least what we're talking about today is the stuff that survived or is available or you can resurrect and you can still make it work and it's fun to play with it and think about it. It's kind of like the people that like to think about old antique vehicles. And you see somebody with the Model A's putting around, and that's great fun. They still work. They're there. They don't compete with a brand new Tesla or something, you know, or one of the new electric vehicles, but they're there and they're fun to play with. And so you have the antique motor car people, just like we have the antique computer people, but you learn a few things. You look at them and you play with them, and there's some of the stuff that you see that makes you say, aha, here's what they should have done. And you may be in the position to suggest, or somebody notices that, yeah, instead of going this way, we should have been going at almost a right angle this way, because going this way is going to be more competitive, faster, cheaper, more convenient, more features. And so we're in a position playing with stuff where we can see those things that we might throw across the wall to some of the young guys that are working on new stuff that can use the concepts, not necessarily the vintage hardware, but the concepts of that vintage hardware. And some of those concepts are great concepts, and they were really available with the new technology that's available. You can take and make that concept work today so much better than you could have if you were back at that time when the concept was initiated.
So, go ahead, please.
So, based upon this, is there something from your, and I'll ask the same question to all three of you guys, is there something from your history with computing that was an absolute dud, just completely flubbed, failed in the market, that you feel a pang of nostalgia for, that you still really love?
I don't have one personally, but the discussion of that I've had with several other hobbyists numerous times, and he mentioned how this period they were just trying any and everything. Who knows
Wild West.
What was going to happen? There were some brilliant ideas and some brilliant companies started. Whoever thinks they're the sharpest probably could have come up with something as well, right? And yet all these people who are just moving forward and great ideas and great marketing even, and whatever their strengths were working towards all those, just got crushed. Like you said, you don't know what's going to happen. When the PC came out, and so it may not be better than what you're doing, but IBM's behind this. And everything went with IBM and clones. And of course, once the clones are out, you're building 10 million of them a year. You can't touch the price of that, right?
Right.
So all these people with all these ideas from this wonderful period I love in the 70s, not so much the home computers, the metal ones that were going to be business computers and stuff, but still personal. They had no idea they were all about to get destroyed. And some of these companies got pretty big, and every last one of them just...
Give an example. Like,
oh, I mean, you got your vector graphics, and you got your North Stars, and you've got your processor technology, and all these companies that were doing some really good things, some innovative things, and you know, none of them made it through this. You feel bad for them, and you're talking about, again, how's this going to work? It's amazing how many of them envisioned they'd all be time-sharing machines. Well, you say, oh, that's stupid. PCs, everybody has their own. Well, every machine you worked on was a time-sharing machine for the most part, right? You couldn't turn this thing, and they were getting more and more powerful. And in the S100 machines, you could put, 4 or 5 processors by the late 70s in there, each with their own graphics cards, and separate the users nicely. But of course, that was a big disaster. PC gave us even more power technically, but reduced it to one person. And then networking became the way it was all taken. So you can never envision this. I mean, yeah, let's do our time sharing. The platform is 1/10 the cost of this DEC mini computer, and we could sell it to these small businesses. But yeah, it ended up not going that way at all.
Now we're back to time sharing with virtual machines and cloud computing.
Yeah.
So one example is, I keep coming back to it, but Centurion is a good example. They started off in 73 with like 6 people, and they grew up to, they got pretty big, up to about 300 people. And I have a piece of marketing material from them from 1983. It's not marketing material, it's a pamphlet that they would give prospective dealers. It has a lot of wonderful information in it. And on one page it says, feeling the heat from the personal computer market, but we still don't consider it a threat. They were bankrupt in less than 12 months.
Oops.
So that's one example. But I mean, there were NCR is another wonderful example. NCR entered the mini computer market with, I want to say it's the 800 or the 1200. I don't know. It had some numbers. This was the mini computer style. Give your computer a random bunch of numbers, much like SUVs of today. It's the QX36, whatever. So NCR entered the mini computer market, had 2 machines that were quite good, and then disappeared, never to be heard from again. I mean, NCR is still around. They make, you go through any Walmart and the scanners made by NCR, National Cash Register, right? Burroughs is another example. They were quite big through the 70s and into the 80s. Sperry, my Basic 4. Has anybody ever heard of the Basic 4?
We're at your table. We're at your table.
There we go. The My Basic 4 was a mini computer manufacturer that was a blip. They showed up, they built a couple of machines, and then the PC crushed them.
Yeah.
Them and everybody else. But we're fully off topic now.
No, actually,
really?
no. I don't think you are. But we have. Pretty soon, I think we'd like to open this up, dedicated for questions from you before we run out of time. But before that question, I keep coming back to Granville here, but I think it's worth it because we rarely do we have an opportunity to celebrate somebody who lived through an era that we're now all celebrating in some nostalgic or even new way in a first time. So I think the final question for you officially at Granville will be, now that you know everything you do, you have the benefit of 45 more years of knowledge since the release of the TI-99 or any of the other machines that you worked on at Texas Instruments. What would you have done differently? What if you could have known what you know now? What one thing or what few things would you have said, we really should have done it this way, that would have made all the difference in the world?
I guess the biggest thing that finally happened that we should have figured a way to make it happen. Of course, communications is really key. And the thing that has opened up all sorts of products is Bluetooth technology. The ability to communicate. And so we could have worked with the FCC and developed the equivalent for Bluetooth technology in the early days rather than waiting to the last 10 years.
Oh, wow.
When it's emerged. We could have been doing that in the 70s. We could have made the equivalent for Bluetooth type technology. It just required to reach a critical point that you pushed it hard enough to make it happen. That you make it a standard and then you leave the standard open so that everybody can use it. It's kind of like the Sony and Panasonic with their VHS recording and with the Betamax recording. The Betamax was better, but they would not release it to the public so that they didn't get the volume. But if we had pushed the communication, the thing that limited home security systems was communications. We were working on thinking about trying with power line carriers or other things, but we could have been working with the FCC to get approval of a band like Bluetooth uses and done the communications starting in the late 60s.
That's fantastic. So think about this. Consider this. If that had happened, whatever technology connects all of our devices to each other individually at short distance certainly would not have been called Bluetooth, because that's a name that only something after the year 2000 could bring you.
Right.
All right, thank you for that. We have about 15 minutes left, and so I think all of you who've sat here deserve to have some questions asked. So, show of hands. Let's see if we have any questions for our panel. Yes, please.
Question for Mr. Ott. So, regarding the TI-99 computer, the story that I've heard was that TI Dallas people had their idea for what that home computer should be, and then TI Houston people had their idea for what the home computer should be, people like Rod Canyon, and that Dallas people won and the Houston people lost. Can you comment on that? Is that in any way true?
Not so much. I don't think each group, the people in Dallas, the people in Houston, and the people in Lubbock, say, as three different groups, had different ideas of what type of products they would like to see, but there wasn't a battle of that kind. The main thing that there was a battle with is that each group wanted their products to be in what was produced. And so they were pushing hard to try to get the end product with as much of their product in it as they could. But that's the way the interaction really was going. And also the concern with, would it impact their current customer base? Are you going to make customers mad if you do this? If you are, or is this other group going to go with product that makes the customer mad, makes my customers mad? I would like to see if I can stop that. And there was some of that going on.
Okay, thank you.
Other questions? I know they're here. Don't be shy.
I'll ask a silly one.
Please, go ahead.
Dr. Ott, TI in the 70s and 80s was also famous for like robotics and automated machines in the office. What was your favorite robot or cart in the TI offices at the time? Like they had automated mail carts that would wander around the office and bring you your mail. Some of them were pretty silly sounding.
Well, the particular robotics that I liked was, I talked about the calculator line, and where they ended up having a maximum of 1 minute of human hand. Everything else was automated. All of those lines were automated, and that level of automation to try to take whatever is going on and just automate it. And I think, but I don't know, some of the semiconductor people can say that, but they were trying to automate as much of the semiconductor manufacturing process as they could. But I wasn't in their centers to have anything other than making computers or designing the computer that they could use for using computers for their part of their automation. In fact, that's why I built the first 16-bit computer for them, was to automate the cat lines that made these semiconductors. You have the best transistors, the pretty good transistors, the not so good transistors, and the AWADs.
Which stood for what?
Ain't worse the damn.
Yeah, we go. There we go. All right, we have a question right over here. You, sir?
The DSP signal processors, I think, originated down in Houston. Is that correct?
Okay, the DSP processors?
Yes.
All right, originate in Houston?
I believe so.
It was a question. Did the DSP processors originate in Houston?
No, actually, the research lab was doing the DSP processor. Harvey Cragen was working on that, and then it got transferred as a product to Houston. And so they then took that and productized it, but it was being designed. Actually, they talked to me about it, about working on the DSP project before I even went to teach in Missouri, while I was still in Houston, and before '68. The Central Research Lab had people working on processors for that and trying to pick the right one to do it. And Harvey Cragen kind of took that mantle. And Gene France then went from our group in Lovett to Houston and carried that forward into its main product, which is still a major product.
Excellent. Other questions? All right. Yes, please.
What do you feel from 1970s computing is missing in modern computing post 1984?
Wow.
I'd love to answer that one.
Go for it.
Well, he looks like he's about to speak. Go ahead.
I was gonna say understandability. The 1970s, I think, saw the shift from a machine that a single person could understand to a machine that takes a team of people to understand. And you see this particularly in the 1980s, where it's like literally impossible for a single person to understand how every gate in that machine works. But you can get back to something like a Data General Nova, and you and I have spent some time doing this, where you can look at the logic diagrams and the schematics, and as a single person you can start to parse where information and data is flowing through it. And so that shift from gate level troubleshooting to IC level troubleshooting, I think is kind of what we're missing in the new, because now it's all just an assembly, right? Like it's like, oh, that failed, I'll just replace this entire board that has 400 million gates on it, you know?
The 1970s computing was pretty sloppy when you look at some of the design work that was on it, and you could build stuff and build it yourself, and it would work. I mean, if you look at the RCA, the Cosmac VIP, like the tiny basic board had one bypass cap, 1.1 microfarad cap on there for 4 EEPROMs and a couple of CMOS logic chips, and one 47 microfarad capacitor. It was sloppy, but it worked, and it just worked. But today, with everything so fast, there's not anybody in this room, I think, that would want to sit down and try to design something with a microprocessor today and try to get the board layouts, because everything has to be equal paths, lengths, and the timing is so incredibly just on point. But now we don't have to worry about that, because we've got Arduinos, we've got the ST32s, and all these other boards that as experimenters we can play around with. And these are our current things that were being done with the 6502s
that
and
whole
6800s.
Chipped
yeah.
In the 70s, yeah.
And you're playing with more processing power and more memory than what some of the biggest home computers, even in the S100 world, had for processing power, memory, storage, everything in the palm of your freaking hand.
That's I always, when I first started in computing, it was still in the aquarium with the raised floors. You weren't allowed to go in there. You go pick up your printout, go give them a deck of cards, all that kind of stuff. And then during my high school, college, and early professional years, it was completely hands-on. We were the only generation that could understand everything from the lowest hardware level to the low-level software to the application software to the display devices. You could fiddle with it yourself. You could fix it yourself. You can't do anything like that now. And when I'm depressed, I go work on this old stuff because I have control over it all. I can wrap my hands and my mind around all of it and make it do something, which you just can't begin to do that. Everything builds on, it's like your Star Wars stories or Coruscant or whatever it is, where the foundation is 500 years of buildings underneath it. That's what a modern computer is. You can't begin to get to the foundation and know what's going on at the gate level. That's why I love the old stuff. It's comforting.
The moral of that story is you can't control anything else in life, but you can always control your vintage technology. All right. Yes, please.
Just to follow up on that, do you think that that's why we have a room this big and we have these conventions, is because we just can't do that with today's technology? But yet, I mean, I'm 50 years old. I was born in 75. you know, I love that older stuff, and I think it is because I can get an understanding
Yeah, I
of
think
that,
so.
as opposed, I can do it myself.
I think a big part of that is that we're old enough and we're comfortable enough with our finances and stuff that we can go out and we can buy the things that we played with as children so that we can play with it again for nostalgia, but also go out and buy the stuff we always wanted to play with as a kid because, you know, somebody else had it, we didn't.
Right, but I didn't play with the I didn't want to play with the PDP-8 when I was younger, but yet that is very attractive to me right now.
Yeah.
And I think that is, I'm just trying to get my head around, you know, why is this?
It's so significant, and yet you could still probably figure it all out and wrap your arms around it. That's a great dopamine hit, you know.
What I want to, I mean, what I think is really significant and encouraging to me is that there's so many people at this event that are like under the age of 35 that think this stuff is extremely cool. It might be 90s technology, but still, all of it is from the time before that they were born. So if I could extract a question from somebody in the room who's 35 or under, I'd like to hear it. So if you're shy, please ask it, because this is kind of cool. Nevitz, I can always count on you. Go for it.
So the 70s is, at least from what I've seen, a lot of where you saw computers getting out of like a lab and into a thing, in factories, in like rail yards, in machine shops, that sort of thing. What is, now this is a question open for all four of you, what is a place you saw a computer like this in a place you didn't expect? Where you opened this thing up and said, oh, that's a computer.
Wow.
CNC machines were always what surprised me. Like seeing paper tape readers on CNC machines. Yeah. I mean, I'm not old enough to have actually seen that. I have a friend who's like into old school CNC machines.
Yeah, you just need to look at the right place. I had a machine shop at one of the Dallas County Community Colleges. They had a CNC mill that had a paper tape reader on it.
Yeah, I love seeing that.
Tape reader. It also had like serial hookup that they had to something running, I think, Windows 98 on it in like 2008.
Yeah. Not that I got to see it firsthand, but I forget the name of the video game. In fact, I think somebody might be out there doing it. Not the video game, the TV game, where an apple controlled the whole thing. Oh, no, wait, no. Apples were each of the 9 screens. Tic-tac-toe.
Yeah.
Apple was each of the 9 screens, and then an Altair talked to all the apples to tell them which picture to put up. I mean, I would never have dreamed an Altair and apples were used on TV. So,
all right. Well, before we get to that question, I want to hear if I could extract it. That's a great question that Nevitz asked, Dr. Ott. What is the craziest thing you've seen a computer in that you were never expecting to see a computer in? Now that we're 45 years after you did all this wonderful stuff at TI.
Well, one of the places that computers showed up in real early was in some appliances, your microwaves. When they change from having a little dial that you twist and it kicks down, you have a little keyboard that you enter. And what's interesting is the company making them raised their price by 10% because it has a keyboard. And the keyboard saved them a bunch of money because the mechanical machine and make one reliably costs so much more than a calculator keyboard.
Yeah, well, that must have happened in the 70s, too, because I have a radar range in my guest house with just such a keyboard, and I know it's from the mid-70s. Okay, go ahead, sir, please.
It's not a crazy place, but the very, very first place I think I ever saw a computer in the wild, I mean, in public, was in like 78 or so. It was in Louisiana. We were living there, Leesville, Louisiana. It was 1978. It was in a Lowe's hardware store, which before big box things were happening. And I only remember it was Lowe's. It's like, wow, they go that far back. It was the middle. The store was arranged where the register area was just square in the middle of the store, and in the middle of that was a mini computer, which I'm pretty sure was a Nova.
Ooh, we like the Nova.
In 1978, and it was what they were using for their store stuff. or their store, register processing, I guess.
Excellent.
Which is really used to that.
I always find it crazy that on the Nova, the first CT scanner that was ever made,
yes,
by GE used a Nova.
Used the Nova. Marcel Van Herk, who we hope to meet someday, does some fantastic presentations on that. All right, we are almost out of time. Who in the room would like to give the honor of the final question of the presentation? All right, yes, sir, please.
I'd just like to know, kind of how marketing shifted for computing devices, from the early '70s to the late '70s, when things were becoming more miniaturized. Was it immediately a thing of oh, we should start marketing this to kind of get everybody on board with computers, or did that just kind of follow as the technology came?
I have an answer for this that is probably to be different than the rest of you. It's the realizing that sexism in advertising is a bad idea and won't age well. There are machines on my table right now who advertised they are the worst sexist advertisements in existence. And I think by the time the mid-'70s came around, they realized that was a really, really bad idea. And I only jumped in there instead of our panelists because I thought that maybe you guys wouldn't have thought of that. What do you guys think?
I grew up in the 70s, so as I grew up, I never saw anything about industrial ads, but you just saw all these little bitty ads coming in, starting with the Atari 2600s, the VIC-20s, George Plimpton with the Intellivision, and William Shatner. You start to see all these people advertising all these computers, and it moved from personal down to business and what you can do for your business. And you start seeing more and more business ads on TV and fewer stuff for home computers for playing games and the kids.
Cool. All right. Anyone else on that before we wrap it up?
As a hobbyist, I was always drawn to all the ads in Byte and all the hobby magazines, all the small ones, just looking for that magic piece of equipment or that magic deal or what I could make with this thing. And the big Madison Ave ads was William Shatner and stuff. I just turned the page. But again, you have different audiences. One ad's not going to work for all audiences.
I think maybe it was the creation of the consumer market audience that didn't exist in 1970 and by the late 70s was heavily sought after. And, they were a threat. And with that, all right, everyone, this has been a fantastic time. Thank you for being here. Let's give our panelists a warm applause.